Hello,
Hello, Professor Javits. How are you?
I'm fine and you?
I'm good. How was your internet connection today? Is it good?
Good. Yes.
Then you can turn on your camera, Javit. I want to see your face. Why do you hide your face? Huh? Did you go to school today, Javits?
No.
No. So when will you go to school? Tomorrow.
I think I will not go to school.
So now you are having class online.
Yes.
Your actually holiday is over, right? You had a holiday last week.
Yes.
You did have school. I see.
Yes.
Good. Okay, Javed, look, seeing your face and having class is much better. When you get tired, you can turn it off. If there is nobody around you, keep it on. When you get too tired at the time, maybe you can turn it off for a few minutes and get back to the class. Okay. Narmin, welcome. Good to see your name again. Okay, today is 30. How are you, Narmin?
I'm good.
And Narmin, I'm hoping that Javit, you you will get a gold medal in Sasmo. Do you agree with me? We have only 3 weeks left, right? And we did a lot of examples. The only thing is in Sasmo, questions are tricky questions, so you have to read it well, and you should actually have a kind of feeling what actually are they expecting from us. If you can actually have that feeling, you can answer the questions quickly, because on purpose they choose such questions that if you do not read it well, or if you do not understand 100%, most probably you will make a mistake, because these questions are non-routine questions, not standard questions. Okay guys, let's start. Okay, we have 3 weeks left, and I'm trying to cover all the questions until 2017, and after that we will see. Okay, last time we started this, we did a few questions from here, I think until question 14, right? We stopped here. Let's continue from here. Let me just put a date here in case. So how many triangles are there in the diagram below? No, I think actually you know the method, right? To count the number of triangles, the number of squares usually they ask, or maybe the number of quadrilaterals they may ask. The method is, for example, triangles, you need to count in a certain way. What is that? Just count the triangles which has only one part, and after that 2 parts and 3 parts and 4 parts and blah, blah, blah. Narmin, can you count this in 1 minute? How many triangles are here?
Okay.
Because I know that actually just looking at the screen and solving this problem, it may be a bit hard. And if you try to draw this, it takes time. I don't know how you are solving this. Narmin, are you drawing with PC, laptop, or iPad, tablets,
Oh, with
or
my
telephone? Huh?
computer. Computer.
So how are you counting now?
Um, I'm drawing on the paper.
Hmm. Javid, did you count? How many did you get?
I got 33.
33.
Yes.
Narmin, how about you? We're still counting.
I'm still counting.
Let's see how many you can find. Javid, 33.
Hello.
Hello.
Sorry, teacher, for being late because before the sunset was at 6 o'clock, and because I was just like this now, it is more like this. There is still like sun, so I just mixed it up.
Oh, it's okay. Actually, I should apologize for starting the class before you and before you join. Sorry.
No, because I was 9 minutes, 9 or 10, 11.
It's okay, Ara. We have just started. Last time we started this paper, if you remember, and we are counting triangles here now. Javid, you said 13 or 33?
33.
33. Narmin, did you finish counting?
41.
Did you finish counting? How many could you find?
I got 41.
41. Let's see if you get the same answer, but we just count together. The triangle which has one part, it is how many? 1, 2, 3, 4, 5, 6, 7,
Is
8,
the
9,
answer
10.
33?
So that is 20. Okay. And how about
Teacher?
two parts? Two parts. Here we have 1 and the 2, right? 3, 4, and the 5 and 6, 7, 8, 9, 10, 11, 12, 13. Right? So two parts we have 13. It's already 33 arats. So we have more. And how about four parts? Right? 4 parts, as you see here, this one, let me just draw like this. This is 1, for example, right? Or this also 1, right? And this is 1, for example, and also this one is also 1. The same thing here, we have 1, right? And also here we have 1, right? How many? 1, 2, 3, 4, 5, 6, right? Is it 6 or we have more? Did I count 4 parts?
It is 6.
This is 1, 2. Okay. No, I didn't count this one. Can you see this one? 7, right?
Also, you didn't count one of them.
Where is it?
1 second. This one.
Okay, so 8, right?
Yes.
It is 8. So now altogether, how many? 41. And how about the big one? 8 parts. If you look at this one, 1, 2, 3, 4, 6, 7, 8. No? 4, 6, 8, right? It's a triangle. And also upper part, right? This one, also it is one more here. Here. Right? Here we have 2 more. So since actually, I think no more, right? Can we count anymore? No, because otherwise it's 10. We don't have any. It will be too big. So altogether 43. Yeah, because bigger than 43, that is 45. And to find more, it must have either 9 parts or 10 parts. That's not possible here, right? So, okay. So the answer is 43. If you can find more, let me know. So Ara said 35 and 33. That's all. Actually, Narmin's answer is the best, 41, but still it's not enough. Narmin, you
I
didn't
forgot.
see the biggest triangle, or you actually made a mistake in counting, which has 2 parts or 4 parts?
I didn't see the biggest triangle. That's
Okay, good. All right, guys, let's continue. That's a tricky question. Sometimes if they don't have, we don't have the choices, I mean, options, it may be a little bit hard, but just we need to count carefully. And in exam time, you need to count at least twice so that you will get the correct answer. And this question, you know the idea, and just we need to draw carefully. 5 circles here. 5 circles are drawn on a flat surface. Again, in some question in Sasmo, and sometimes they ask in a flat surface, and sometimes they ask on a rectangular sheet of paper. Okay, these questions are different questions. Sheet of paper, that means that it has boundaries, right? On a flat surface, where does it end? We don't have any boundary, so you have to consider this. What is the greatest number of regions that can be formed on the surface? And can you try this, and how many you can find? How many can you find? Actually, how many regions we can make?
Is it 20? Oh no.
How many?
I got 20, but I think it is wrong.
How many? Circles, 5 circles.
No, I will change it. I will change.
If you don't have a compass, with hand and you draw this, you may not be able to see this well because the intersection parts are getting smaller and smaller.
Is it 21?
Is it 21? I think it's more than that. How many circles? 1, 2, 3, 4. Okay, it's a lot. How many do we count like this? Here we have started from here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18. Because this blue circle, right, it should actually move this. If you don't draw this ball, as I say, we cannot uh, say this because it must also intersect with the red circle. It's not intersecting. Anyway, how do we?
Actually, there is another way without drawing,
How?
but it will be accurate. 1 second, because there is a pattern. It is like this. 1 second. Like this one is 3. If you like see, there is oh, oh, there is one middle one, and there are 3 stars, and also 3 itself. And then if we now draw 4, and again, 1 second. Again, we have one middle one and 1 4, as it was like in this 3 pointing, and also another 4. So and this one. So like if we count n, 1 second. Like if now this one is 3. Now we have n. This 3 or 3 itself, it depends on the number. We have n plus and 1 and plus this 3, which is plus n minus 2 and times n. So we get quadratic n plus n plus 1. And in 5 we have 25. No, something was wrong. Like in here we have 3 plus 1 4, 4 plus 3 7, 1 2 3 4 5 6 7. In the 4 one, if we input now n as 4, we get a 1 2 3 4 5 6 7 8 9 10 11 12 13. And in here 4 plus 1 5, 5 plus 8 13. And now we do the same for 5.
So what is the answer then?
21.
So what is n?
And 5.
5.
Yes.
So how do you get 21 from here?
No. I think there is one thing wrong in my equation, because when I like drew it like that, I got 21.
Yeah, that's why I'm wondering actually that formula actually works for it or not. Anyway, if you count this, it is 21, right? And plus outside we have one more time, one more, because also outside region we need to count this as one region, so that will be 22. Okay, so when you have time, you can just draw this in such a way that when actually here the idea is when circles create more regions if they intersect each other at 2 different points, right? Because 2 circles, either they may not touch each other at the time. We have here, we have 1 2 3 regions. And how about if they touch each other? We have only again 3 regions. And how about if they intersect each other at the time? We are creating more regions. That is 1 2 3 4, right? So to do this one, actually, every circle, it must actually, when you just draw any circle, it must cross the remaining circles at 2 different points. Okay. Now, if I just draw this using the circle, it may be a bit messy, but at the time you will see that there will be 21. One reason I'll say that it will be 22. Is there any algebraic formula? Let's just do some research, and if you just get anything, let's see. All right. Also, I'm interested because they're asking the similar question again and again and again. Okay, but usually, so far what I know the way is we need to draw and nicely and count it. Okay, is there any algebraic way here? I don't know. Okay, but because if you're claiming that something is true in math, you must prove it. Okay, if you don't prove this, we cannot take it as a fact. Okay, let's move to the next question, and I need to delete them. Okay. How many fractions are there in the sequence below? And I think, I don't know, is it a difficult question or not? Usually in this kind of questions, we need to find a pattern, right? If you don't see the pattern, of course, we cannot count one by one. And first think, okay, let's just give 2 minutes. And after that, we may share our thoughts with each other. How can we do this? And we'll try to find a pattern here.
I found a pattern.
What is it?
And numerator plus denominator is equal to this one.
Okay.
And 1 second. And 1 plus 3 is equal to 4. 4 plus 7 is equal to 11. 11 plus 18 is equal to 29. 29 plus 47 is equal to 76, and so on.
Okay.
It's like Fibonacci kind.
So it's like, so we can just write a single fraction, right? Also, actually, from here, the first we just write 1, and after that 3. 1 plus 3 it is 4. 4 plus 3 it is 7. 4 plus 7 that's equal to 11. 7 plus 11 that's equal to 18. And 11 plus 18 that's equal to 29. 29 plus 18 that's equal to 47, right? And what is it? 29 plus 47, 60.
76.
76. And 76 plus 47, 121.
123.
23.
23.
And if you add this, it is 190. 199. Is it? And after that, if you add this 123 plus 199, it is plus 1. So it is 322. And this one, add one here, 200. That's equal to 521, right? And add 1 again, that's equal to 843, right? And 843 plus 521, 1300, 1364. Yeah, we got the actual the last one, and after that, of course, that's just 2207. I see. Okay, until here. We know that actually two numbers, they actually form one fraction, right? Here we have this one is 1, and this one is 1 for over 7. How many pairs do we have here? 1, 2, 3, 4, 5, 6, 7, 8. So here we have 8 fractions here. Because the question is, how many fractions are there? There are 8 fractions here. Okay. Javid, can you read the question? Also, while you read this, I can have a little bit rest. And sometimes listening to somebody is also good. We will
The bar
improve our
chart
listening
below
skill.
shows the number of cars sold in town A in the first half of the year to 2015. For example, 7,300 cars were sold in January, while X thousand cars were sold in February. The number of cars sold in last 2 months is not indicated in graph. The percentage increase in the numbers of cars sold from February to June in 40%. The number of cars sold in May is 2,800 cars, less than twice the number of cars sold in June. The product of number of cars sold in May and June is equal to 170 million 600,000. 600,000, yes. How many cars were sold in February?
I don't know if you have ever used Singaporean books or Singapore syllabus, let's say math books. There are a lot of questions like this. You need to read and understand first, and after that, and whatever, it's a bit long. But usually British system, UK system, but Singapore system is more than that, a little bit more challenging. So anyway, this is actually related to statistics. I think so far we have never solved any question related to statistics, right? That's the first question. That means that now you need to expect one statistics question also in the current year Sasmo paper. You should understand, you should read this, and if possible, you should read twice. And after that, we try to solve this question, because word problems, if you are not too smart, usually most of the people at the first reading, we may not understand 100%. So that's why what is suggested here is read it well, I mean, quickly, very fast to get the general information. And the second time, read a bit slowly and holding a pencil and take a note. If possible, introduce a variable, formula equation, and solve it. Now, before we read this for the second time, let's have a look. So we are talking about this bar chart, right? And bar chart shows here the sales of the car in the first half of the year, from January to June. So in January, 7.3 thousand, that is 7,300 cars were sold. February, X, March, 8.8, and April, it is 9.4. May and June, it's not given here. Okay, maybe of course if you just measure with the ruler you can find this, but here we need to solve this using algebraic way. So in the question it says that the number of cars sold in the last 2 months is not indicated in the graph. Okay, the percentage increase in the number of cars sold from February to June is 40%. Okay, first let's understand the question. After that I will give you some time, then we will discuss together. So the percentage increase of the cars sold from February to June, it is 40%. So the number of cars sold in May is 28,000 cars, less than twice the number of cars sold in June. So what is it? The number of cars sold in May is, in May, here we are talking about May, is 2,800 cars, less than twice the number of cars sold in June. The product of the numbers of cars sold in May and June is equal to 117,600. 117,600,000. How many cars were sold in February? And I really want to put this in the same graph, but it takes. Let me just put this in the same graph so we can see this, okay? Say again.
Can we give approximately?
How?
I got the answer, but it is about like a repeating decimal.
What's your answer?
Once again, 28,666,6 repeating.
Just a minute. What is the answer? Say again.
Once again, I will write it to chat.
How many cars were sold in February? X. What is it?
Once again, I will send it because it's hard to say.
No, just tell. How come is it hard to say? Is it more than 1,000?
Yes.
How much is it? Just tell me.
28,000, 28,666,6 repeating.
Yeah, Arad, how is it possible? Can't you see the bar chart? It is shorter than January. In January, 7,300 cars were sold. It means that in February, it is less than January, right? It's less than 7,300.
On this graph is from the question.
Of course. Actually, using this bar chart, you need to answer this question. Okay, shall we do it together?
Can I say my way? Because I think it is correct.
The first May and June, did you actually connect in the question is saying that, right?
Yes.
Let me just
I wrote in terms of X, then I added them. It was
the
this one.
percentage increase in the number of cars sold from February to June is 40%. Right? So what does it mean? What does it
So
mean?
June is 1.4x.
So actually June, that is 1.4x. Okay.
And May is 2.8 minus 2,800.
So the number of cars sold in May is 2,800 cars, less than twice the number of cars sold in June. So in June twice, so that is, we can just write here, twice, that is 2.8x, right? Minus 2.8. Okay, we are also done with this. Now it says that, huh?
Why 2.8?
Because it says twice, right? Twice the number of cars sold in June.
This 2.8.
No, it says that the number of cars sold in May is 2,800 cars, less than twice the number of cars sold in June.
I know, but why it is 2.8? Why not 2,800?
Now here everything is thousands, right? You see it thousands.
That way. Okay.
Okay, this 7.3 means 7.3 times 1,000. Anyway, so that is 2.8x minus 2.8. The product of the number of cars sold in May and June. In May and June is 117,600,000. So that means that 1.4x times 2.8x minus 2.8 is equal to, what is it? 117,600. Because we are counting everything in thousands, right? That's why we don't have to write the last three zeros. That's it. Now from here,
Teacher,
yes.
why did you multiply them?
It says that the product of the number of cars sold in May and June is this, right?
On the product or the sum?
I don't know. I can read it as a product. Do you read it as a sum?
No, I thought that like because it is car a product, it means like the product itself. No, I added them.
Oh my gosh.
My problem is with English. Because I went completely the same way, just I so that product is the product which is out of the company.
Your product, your problem is with your English, Ara. That's why you are here. If you didn't have a problem with your English, you wouldn't be here. No, that's.
Why you should like multiply two things like number of output? You have to add them.
That is the art of language. I'm expressing everything in the same way. It may be boring to make our sentences more beautiful, right? That's why we have synonyms. Synonym means sometimes which one is better we have to use. The multiplication of number of cars, it doesn't sound good. That's why actually in math we use the product.
But why you should do like multiply the number of cars?
If you do this, okay, because this one is it is a business question. In business questions, they don't use mathematical terms much. because multiplication, it is a pure mathematical, let's say, terminology. Anyway, Arat, the product means multiplication. Just accept this, okay? You are asking that, I'm saying that, Arat, here in front of me, there is a computer. We call this a computer, this machine. And you are asking, why is computer? Why something else? How should I call this? Okay, if I say it's a chair, again, you question me, why not computer? Okay, the same thing. So we should actually uh, have a convention at some points. So we should actually agree with each other. Anyway, the product of the number of cars sold in May and June is equal to 117,600,000. So 2.8, 2.8 is a common factor. Take this out, and 1.4 times 2.8, and here we have x, and here we have x minus 1. That's equal to 117,600. And now from here you can simplify this. X times x minus 1, that's equal to 117,600 is divided by, what is 1.4 times 2.8? It is 1.4. It is 1.96. 1.96 is multiplied by 2. It is 3.94.
92.
3.92.
Is 6 at the end. 6 times 2, it is 2.
Okay, good. And how about 117? Here we have 600 divided by 3.92. It is 30,000, right? That's equal to 30,000. I'm making a mistake somewhere here.
And notice it is a mistake because now it will become quadratic.
Now on the right hand side, it should be 30,000 or 30.
No, because 1 second, then you get this one.
No. On the right hand side, it must be 117.6, right? I'm talking about this one.
No, teacher, because you crossed 3 zeros.
No, because here, this x is in thousands, right? And also these are in thousands. Thousands times 1,000, that's in million.
Teacher, but this one is a million. If you do that, it will become 0.0028.
No. If you just divide this by this, what is it? That's equal to 117 times 6 times 1,000 squared. So on
Yes,
the left
teacher.
hand side, I'm here. I have what does it mean? It means 1.4x thousands, right?
No,
Times
teacher.
2.x minus 2.8 thousands, right? So now I'm just dividing both sides by 1 million. So at the time, here we have point, because here we are multiplying thousands. Everything is thousands. On the right hand side, we have also a medium. We should divide both sides by 1,000 squared. So that's equal to 30. Now from here, it is just the product of two consecutive numbers, right? So from here, x is equal to 6, or x is equal to minus 5. Minus 5 minus 6 over 30, or 6 times 5 over 30. And it's a positive number, right? That's why this answer is rejected. So what is x? Then x is ... x equals 6,000. That means that 6,000 cars were sold in February. Javi, did you understand?
Yes.
Very good. Javid, I can see you so clearly. Why? Is it too much sunlight there, or?
No, I turned on lamp.
I see. Very good. I wish I could see everybody's face like you, Javid. That's my wish. I hope one day it will come true. Okay, let's continue. That's it. I think they are not so statistics questions. Usually they are not so hard, but if you just know how to do that, if you have some information, that's it. We don't have much in statistics. Anyway, Arat, read the next question. Let's continue.
There are 27 students in the classroom. 14 of them wear glasses. 11 of them are girls. Only 5 boys don't wear glasses. How many girls wear glasses?
There are 27 students in the classroom. 14 of them wear glasses. 11 of the 27 are girls. Only 5 boys do not wear glasses. How many
3.
girls wear glasses?
Is
Huh?
the answer 3?
I don't know. Why?
Because firstly, there are 16 boys because 27 minus 11. So 16 boys are in total. 5 of them don't wear glasses. 16 minus 5 is 11. So 11 boys wear glasses. 14 minus 11 is 3. And now 3 of the girls are wearing glasses.
Okay. Now here we just draw, right? It says that what is that? We have, let's say, wear glasses, and what we have here, girls, let's say. It says that 14 of them wear glasses, and 11 of the 27 are girls. So girls, that means that here we have, let's say, here we have X, Y, Z. 11 of the 27 are girls. That means that Y plus Z, they are girls. Only 5 boys do not wear glasses. So that means that 21. So here we have 11, right? There are 27 students in the classroom. 14 of them wear glasses. Girls, okay.
I think the Venn diagram has to be 3 circles.
Boys, we don't need them, right? Here, wear glasses. And how many people wear glasses? X plus Y, that's equal to 14. And 11 of the 27 are girls. How many girls? That is Y
I
plus
didn't know
Z,
anything.
that's equal to 11. And only 5 boys don't wear glasses, right? That means that X plus Y plus Z, that's equal to 27 minus 5. That's equal to 22. So Y plus Z is equal to 11. From here, what is X? X equals 11. If X equals 11, Y is equal to 3. If Y is equal to 3, Z is equal to 8. So this should be 11, this should be 3, this should be 8. What is the question? How many girls wear glasses? So that is 3. Okay, Javid, is it clear? Arat, is it clear?
Yes.
Okay. All right. Narmin, can you solve this question for us? In the diagram on the right, what percentage of the grid is shaded?
Impossible.
Hmm?
I don't know how to.
Impossible.
Let's think. Okay, let's just 2 minutes, and after let's discuss this. Let me set the timer, and after that, I'm also thinking. They don't ask impossible questions here. If they ask impossible, then the answer will be impossible. In the diagram on the right, what percentage of the grid is shaded? It's a very easy question. I think it's not difficult. Narmin, what do you think? Can you solve this problem?
I'm trying to solve.
Okay, let's try this. I think just we need to use similarity, right? Because similar triangles and their area, what is it? We know that if two triangles are similar, the ratio of their areas is equal to the square of the ratio of their any two corresponding sides. So if I just actually label this one as, for example, let's say A, B, and C, and this one is D, and this one is E, right? Now from here, triangle ABC is similar to triangle ADE.
Can you wait 1 minute?
Yeah, I'm waiting. I just actually wrote this, okay? Use this one, and if you have any other methods, okay, and you can get the answer. Javid, did you get it?
Is it 8%?
Yeah, it is 8%. Now from here, right, and suppose that the area of ABC, let's just call this S1, the area of ADE S2. So that means that S1 over S2 equals the corresponding side. This AB, that is AB over AD. AB over AD squared. And what is AB? AB is 2. And what is AD? It is 5 squared. That's equal to 4 over 25. Now from here, what is S2? It's just a right angle triangle, right? 1 over 2 times height. Height is 5 and base is 4. That's equal to 10 units squared. So from here, that S1 over 10 is equal to 4 over 25, which means that S1 is equal to 40 over 25. Or by 5, it is 8 over 5. So the area of the shaded region. What is the question? What percentage of the grid is shaded? To find the percentage, we can find here the shaded part is 8 over 5. Out of how many? It one is 4 by 5 grid, right? So that is 20. And multiply this by 100%. If you just simplify this one cancels each other 5, and that's equal to 8%. So 8% of the diagram is shaded, or the grid is shaded.
It's actually this easier way as well.
Easier than this?
Yes.
What is it?
Like till here was the same. I mean this triangle, the area is 4 to this one 25. So I 25 times 2 we get the full area. Once again, the full area of this one, so it would be 5 to 50. And 5 to 50 times 2 both sides, so you get 8 to 100.
Good. That's right. So the total area is equal to 2 times S2, right? So that means that S1 over S, that's equal to S1 over 2 times S2. We know it is ratio 1 over 2. What is S1 over S2? That's equal to 4 over 25. And to express as a percentage, multiply by 100%, that's equal to 8%. Good. All right, I think it's clear. Let's move to the next question. Find the value of the expression. I think it's also a very easy question, but let's see. What can we get here? Two plus one, 2 times 2 over 3. 2 plus 1 over 2, 2 plus 2 over 5, 2 plus 1 over 3, 2 plus 2 over 9. What's this? Okay, so we need to find the expression that's the product. Let's say this S, right? S, here we have 2 plus 1, 2 plus 2 over 3, and 2 plus 1 over 2, and 2 plus 2 over 5, and 2 plus 1 over 3. What will be the next? 2 plus 2 over 3, 2 over 5, it is 2 over 7, right? And 1 over 2, 1 over 3, next one will be 2 plus 1 over 4. Next one will be 2 plus 2 over 7, so it is 2 over 9. And that is 2 plus 1 over 5. Oh, 2 plus 2 over 9, I think we should stop here.
How did you get this pattern?
And as you see here, this one is 1, 1 over 2, 1 over 3, and the next one will be 1 over 4, right? And this one's 2 over 3, 2 over 5, 2 over 7, 2 over 9. Here, alternating fractions, right? So now, if you just simply, did you see the pattern? All right.
Yes.
So here we have 3 times, this one is 6 plus 2, 8 over 3. This one is 5 over 2. This one is 12 over 5. Or should I continue like this? 7 over 3, 16 over 7, 9 over 4, 20 over 9. 9, 9, they cancel each other. And 5, 5, they cancel each other. 7, 7, they cancel each other. And
16 and 4.
12, 3, 4, they cancel each other. And 3, 3, they
2
cancel
and
each
10.
other. And 20, that is 10. So 8 times 16, that's equal to 148. So 148, 0. Is it? Or no. It's 28, right? Because 8 times 16, right? 8 times 16, 8 times 16, 128, and multiply by 10, 1280. Okay, gentlemen, thank you very much. That much is enough for today. Okay, keep practicing. Only 3 weeks left, and I hope you will get gold medal. And let's just do our best, and I hope it will pay off. Have a good night. See you on Friday. Okay, bye
Bye.
bye. Bye bye.
Goodbye.
Bye bye, Javits.